Okay, continuing our discussion on the dot product of two vectors, we're going to go ahead and kind of see how this breaks down. So we looked at previously adding two vectors together or subtracting them, but taking the dot product of two vectors is kind of the same but a little different. Okay, so when we do this, as I stated before, this is the definition of it, but we can also take it into its components, okay? So if we don't know that angle between the two vectors, we can also put it into its component form and break it down this way, okay? So how I think of this in mathematics or throughout physics is if I have two vectors, A and B, okay, I will write them down like so. So A sub x, comma, A sub y, comma, A sub z, if I have three vectors, or I'm sorry, three components, okay, dot product with B sub x, B sub y, and B sub z. Okay, this is how I like to think of it. It might make a little bit more sense. So I'm taking my A vector and my B vector here, okay, and putting a dot product, or dotting the two together. And so what I do is I take A dotted with B, right? So I have my A sub x dotted with B sub x. That's my first portion. And I'll get this. So A sub x times B sub x. Okay. Plus A sub y times B sub y plus A sub z times B sub z. So this is how you break down a dot product. Okay. And when you take the dot product between two vectors, you should end up with a quantity that is scalar. Okay, so this should give you a scalar quantity. Okay, I have a couple of properties here, and one of them is that they are cumulative, that you can switch between the two of them. You can say A dot B is the same as B dot A. Okay, and another thing is this additive property, where if you have two vectors B plus C adding together and you're dotting that with A, you can kind of not quite FOIL, but it's very similar. You do A dot B plus A dot C. Okay? All right. So another thing or tool that we use in physics is something called the vector product or the cross product. I'll tend to call it the cross product, and it is defined in this way. So we say the magnitude of A cross B is equal to the magnitude of A times the magnitude of B times sine of the angle between them. Okay, now this one's a little bit different because this one, if we are just taking the cross product, not the magnitude, that's what these bars mean. This means the magnitude of the vector. Okay, that's what these two bars mean. Okay, if I say the magnitude of, R bar, that's the same as saying R. Okay. Now, if I'm not taking that, if I'm just saying A cross B, okay, this will result in another vector. Okay, so that's one of the main differences between a cross product and a dot product. Okay. Also, I've got a couple of properties like the other one. This one is not cumulative, but we can do something similar just by adding a negative sign. Okay, so A cross B is equal to the negative B cross A. Okay. Also, we have the additive property here. A cross B plus C is the same as saying A cross B plus A cross C. Okay. If you haven't taken cross products before, we can go over that in another lecture time maybe, or maybe I'll do it through when we go through some examples, okay, later on down the course. Okay, but I did want to put in a bit of other rules, okay? So remember that our unit vectors are I hat, j hat, and k hat when we're looking at the Cartesian coordinates, okay? And there are a couple of, maybe not rules, but products that come out of this. So if we take our unit vectors and we cross them, so we have I cross I, so the same unit vector cross itself, the result is 0 always. Okay, so we have I cross I, j hat cross j hat, or k hat cross k hat, it all equals 0. Okay, so when we have this case, we know now that these two vectors or unit vectors are parallel to each other, right? So this is saying that this I hat and I hat are parallel. Well, that makes sense because they're the same vector, okay? Now when we go to taking the cross products with each other, okay, so if we take I hat cross j hat, we'll get positive k hat, okay? If we take j hat cross k hat, we'll get positive I hat. And if we take k hat cross I hat, we'll get positive j hat. Now notice this has a cyclical order to it, okay? So if I take this one, for example, to start with, but then I move everything over to the left kind of thing, and then take I on the other side, now we have j cross k equals I, okay? So just notice that order when taking these cross products, okay? I also have here the full write-out of what taking a cross product will give you, okay? If we take A cross B, we'll get some, what's it called? Some product A sub y times B sub z minus A sub z B sub y, and this will be multiplied by our I hat, okay, our x component, and so that kind of cycles through throughout. And this is based on matrices, which you may not have seen yet, so I won't really go over that unless you guys have the want to. You can email me, message me, but this is the idea here between our cross products, okay? I want to mention that, again, if we have two vectors, so how about, let's see, if we have some d vector cross some f vector, okay, and that equals 0, okay, this means that these two vectors are parallel to each other, okay, kind of like what I was mentioning up here, but this kind of is simple since they're the same vectors. But if we have some random vectors and we take the cross product and it equals 0, that means that these two are parallel. Okay, now let me go back to the dot product. Okay, if I take dot products between D and F, and that equals 0, this means that these two are orthogonal. Okay. or they have a 90-degree angle, okay, between them. All right, so that was a lot of math, but hopefully you were able to follow along through these lectures, and I will have all of this up, including your short little homework assignment that you need to do this week. But other than that, I hope you guys have a good start to the semester.